Welcome everybody to 12.3, an introduction to probability. So today we're going to talk about simple probability. Some of it's going to be review from your past math, but keep watching because it does get more difficult, especially once you get to example 2. So we are going to throw in probability using the combinations, permutations, and fundamental counting principle we've learned in sections 12.1 and 12.2. So please make sure you watch the whole video. Just fast forward through this first section if you want to, but make sure you watch the example 2 and 3. So probability. Here's a definition for probability. It's a number between 0 and 1 that indicates a number between 0 and 1 that indicates the likelihood of an event to occur, an event occurring. A number between 0 and 1 that indicates the likelihood of an event occurring. How likely is something to happen, basically? And when I think about probability, it's a continuum, and it is only from 0 to 1, okay? So you cannot have a probability greater than 1 or greater than 100%. Sometimes students will try to give me answers greater than 100%. You can't have a probability greater than 100% probability. Probability can be represented in several different ways. I can have it as a number or a percentage. If I have 100%, we know the event is certain to occur. And just as a matter of comparison, I also could have it as a fraction. So if I wanted a 50% probability, I could write it as 1/2, I could write it as 0.5, or I could write it as 50%. And for this class, any of these are correct. Sometimes I will recommend one over the other. But also, if you're going to convert from a fraction to a decimal, you have to round correctly to get full credit. So don't convert from a fraction to a decimal and round incorrectly because you'll get it wrong. So be careful with your rounding. We use p to represent probability. So here when I said p equals 1, I meant probability equals 1. And here on this end of the continuum, probability equals 0. And if it's a 0% chance, you know for sure the event will not occur. And when I say event, maybe I'm talking about the percent chance of rain today. Or maybe I'm talking about the percent chance that I'm going to win this lottery ticket that I bought. That's what I'm talking about when I'm saying an event. So event just means like a dice roll or a card draw, something like that. Alright, theoretical probability is a probability that you are most familiar with. This is when I have a situation and all outcomes are equally likely. Or we can predict what's going to happen because we can know how likely each outcome would be. So here's how I would formally write this. When I'm doing probability, I use p with a parentheses, and the thing in the parentheses is what I want. So I would read this, the probability of event A happening. So the probability of event A is the number of ways to get A divided by how many total outcomes there are. This becomes more clear if I show you some examples. Most students don't just memorize that. That is Miss Olson's definition, not straight from the book. Let's look at example 1 and I'll tell you more. So let's say that you roll two six-sided dice whose sides are numbered 1 through 6. I want to find the probability of rolling a 4. So in probability language, I would write P4. And when I say a 4, I should be more specific. I mean a sum of 4. I don't mean just the number 4, and I meant to mean a sum of 4. So please get out your dice sample space that we should have done in class. Get out your dice sample space. When I look at that, The only ones that roll to be a sum of 4 would be 1 and 3, 2 and 2, or 3 and 1. So there's 3 of them out of the 36 that give you a sum of 4. And now I told you you could have this in several different ways for your answer. You could have fraction, decimal, or percentage. You have to have it reduced if you're going to leave it in fraction form. You can't have it unreduced. You'll lose points. You have to reduce your fraction if you were going to leave it in fraction form. And then let me just talk a little bit about what I just did. There's 3 outcomes of rolling a sum of 4. Here they are. There's 36 possible ways I could roll these 2 dice. 36 outcomes total. That's how I came up with those numbers. When I reduce this fraction, I get 1/12. And if I round it, it's approximately 8.3 repeating percent. Let's keep going. All right, now I want the probability of a sum of odd. A probability of a sum of odd. So look at your dice sample space. Look through. So for example, 1, 2 would be a sum of odd because 1 plus 2 is 3. So go through, look at them. I'm not giving you 100% enough time to do this, but if you look through and counted all the ones that add to be odd, half of them do. There's 18 of them. So 1/2 or 50% or 0.5 is my answer for that one. Next, I want to find the probability of a sum of 12. So look at your dice sample space. How many of those add to be 12? And there's only one of them this time, 6 and 6. Find the probability of rolling a number less than 7. And what I mean here is the sum is less than 7. So I'll fix that next time I do this. Sorry about that. Find the probability of rolling the sum of numbers less than 7. So I'm looking at my dice sample space. Anything that's at 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and below all are going to work. And when you count those all up, there's actually 15 of them. So 15 out of 36 is my probability for that. Part E, a spinner has 8 equal-sized sections numbered 1 to 8. Find the probability of spinning a 6. All right, so this time there are 8 sections they told us, and we can assume that there's only 1 6. So 1/8 would be my answer. All right, same spinner for F and G. Now I want to find the probability that I have spun a number greater than 5. There's still 8 possibilities. How many numbers are greater than 5? So 6, 7, or 8 would be greater than 5. So there's 3 of them. So 3/8 is my probability. Now what's the probability of spinning an odd number? Okay, still 8 numbers. The odd numbers on the spinner would be 1, 3, 5, or 7. So there's 4 of them. There's 4 things that are odd. So 4/8 or 1/2 is the answer for that one. Okay, so that was kind of the quote easy stuff, because I know some of you might remember it, but some of you probably don't. So we definitely will be practicing that more. Here's where it gets a little bit more tricky. We're going to now bring in the permutations and combination stuff we learned in 12.1 and 12.2. Example 2a. You play an album with 8 songs on your iPod. You set the iPod to play the songs at random. The iPod plays all 8 songs without repeating any song. What is the probability that the songs are played in the same order they are listed on the album? What is the probability they're played in the same order they are listed on the album? When doing these word problems that are little harder, I recommend to students that they write down what you're looking for in words, if you can. That's going to help out. So basically, we want to figure out how many ways could these 8 songs be played. So on bottom of my fraction, the total number of outcomes is how many ways the songs can be played. And we're specifically talking about rearranging, playing them in all these different orders. So I got 8 songs, and they're going to come up in all these different orders of music here, or orders of songs. So that is a permutation then, and I have 8 songs, and I'm going to select and rearrange all 8 of them. So for my probability, there's 40,320 ways all these 8 songs could show up on the CD or the iPod. Kind of crazy, huh? So that part, we use the permutation. Now let's go back and think about the top. So on top, you always put what are you looking for the probability. And I'm saying, what is the probability the songs are played in the same order? So how many ways could it be played in the exact same way it's listed on the album? If you think about that, there's only one way. If you look at your album, there's only one way that it's listed in order. So there's only one way that I'm looking for it to be played exactly in the order it's listed. When you type that in, everybody try it right now. I'm just going to throw it out there that I'm guessing your calculator says something like this. It probably has a long string of decimals, and then you see e to the -5. Everybody try it and see if that's what you're getting. I want to just, in case you haven't talked to me about this yet this year, that's your calculator's way of doing scientific notation. So it's 2.48 times 10 to the -5 is what's happening. And hopefully you remember this from science class, but when I have a -5 for my scientific notation, I move my decimal to the left 5 places. And now when I move it to the left 5 places, there's 1, 2, 3, 4 open spots that I need to add zeros on then. So 0.0000248 is actually the probability. Really, really, really small chance of that happening. Look at example 2B. Now you have 4 favorite songs on the CD. What is the probability that 2 of your favorite songs will be played first? And sometimes this takes some thinking outside the box. So I'll just do this one again. If you're thinking about it, we're only going to listen to 2 songs. Because what is the probability 2 of the songs are played first? So I am only going to pick 2 songs from here. And it doesn't actually say anything about order. It doesn't say that, you know, this song is coming first and this song coming second. It just says I want 2 of the songs picked. So that means it's a combination situation. So out of the 8 songs, by the way, I should say this is the same iPod album as you had before. So there's still 8 songs total in the album. So you want to pick 2 of them. So there's 14 ways, 8 combination 2 in my calculator, 14 ways that I could pick 2 of the 8 songs from the album. Okay, and now we have to think about the other part. We have to figure out how many ways I could pick my favorite song. And here's one thing that's hard to wrap your head around. We have to assume that it happened. When you're doing probability, always assume you got what you wanted. So assume we know for sure 2 of your songs, for the top at least. Sorry, for the bottom number, it's just how many are possible, how many possible outcomes. But on top, we gotta assume we got what we wanted. So assume 2 of the songs got played out of your 4 favorites. So out of your 4 favorites, we know for sure 2 of the songs got played. So there's 3 ways that I could pick 2 of your favorite songs out of the 4. Please write down questions if you have any on that one. That one's definitely trickier. When you're finished writing, we'll do one more and then we'll go to the next video for the last part of it here. Alright, I've got 5 cards being drawn from a 52 card deck. What is the probability that 2 of the cards are red? Okay, so once again, if needed, write down in words what's happening. So I want to choose 5 cards out of the 52. What is the probability that 2 of them are red? So again, on the top part of the fraction, assume we got what we wanted. So assume that we got red cards. So we're only going to look at the red cards. There's 13 of them, and I'm going to pick 2 out. You know what? I just did that wrong, but I will fix it in the next video because I'm about to run out of time. So, because there's 26 red, right? 13 diamonds, 13 hearts. Okay. We'll see you in the next video, and